Hello, welcome to my channel. In today's video, we are exploring the design of an automatic ceiling fan regulator switch. We achieve this using a temperature sensor, an Arduino Uno board, and a relay circuit. Here is an image of a ceiling fan and its regulator switch. I will be demonstrating how it works. But before that, let's briefly look at the configuration of a ceiling fan regulator switch. Older ceiling fan regulator switches were made of coils with different numbers of turns to provide speed level calibration. If you watch my previous video on the automatic AC standing fan regulator switch, you will understand this circuit better. Unlike the standing fan, whose speed coils are on its head, the ceiling fan has its speed level coils in its regulator switch. Let me show you how the configuration looks. I'm using inductors to represent the coils. I adjusted their values to achieve the speed level calibration. This rotary switch acts as the wiper, connecting all of the coils but making contact with one at a time. This jumper represents the off state of the fan, and these inductors represent speed levels 1, 2, and 3. I will use the default terminal to show the incoming supply and the outgoing supply to the fan. This is the incoming power from the source. The hot wire is what needs to be regulated, so it runs from the supply to this regulator terminal. Here's the configuration inside. The wiper or knob rotates from 0 to 3 and back to 0. When the hot wire is supplied from the power source, rotating the knob to make contact with any of the coils immediately conveys power to the fan. As labeled, this place and this place are now connected together. So power flows to the fan when rotated. For the automatic design, if you watched the AC standing fan video, you'll know that I didn't change anything much nor at all in the programming codes. I replaced the standing fan with a ceiling fan and its regulator switch. I formed this regulator to represent this one. In this regulator switch, I removed the wiper or knob structure, resulting in this setup. The terminals of the coils where the wiper makes contact are then designed like this. The coil speed terminal labeled R is connected here at the normally open terminal of the relay. The same applies to the second coil speed terminal labeled B and the third coil speed terminal labeled G. Power flows from the source to this regulator to keep the coils active. The temperature sensor, microcontroller, and relay circuits now serve as the wiper. In the physical implementation, these voltage regulators supply regulated voltage to the relay circuits while being monitored by the microcontroller to check for power shortages. As the room temperature increases, power moves from one relay to the next. The motor represents our ceiling fan. The neutral wire is connected here as seen in the one it is representing, and the commons of the relays are looped together to connect to the fan, labeled as the fan branch. Here are the programming instructions. As you can see, this uses the same code as the AC standing fan. Now, let's run our simulation demonstration. At level 1, the relay is energized. Starting from the off position below the temperature threshold, none of the relays are energized. You can see this from both the indicators and the screen, which shows the fan is off. As the temperature increases above the threshold, Relay G is energized with its indicator blinking. More increase in the temperature causes Relay B to be energized with its indicator blinking. And then greater increase in the temperature triggers Relay R with its indicator blinking, thereby increasing the fan speed in that order. We've come to the end of the demonstration. I hope you learned something valuable. Thanks for watching. Subscribe to my channel for more updates.